I'm sorry, I'm recording this, so I'm going to have to repeat what I just said. Okay, so what I suggest that you do, those of you that are still on the PDF file, have on your browser one tab of the PDF file, and the other tab, the camera that shows the whiteboard. Please pin the camera so it's big and you can see what I'm doing on the board here. All right, now also you want to get out your periodic table so that you have the ion chart in the back. One of the important aspects of writing a balanced chemical equation is writing the correct chemical formulas. And knowing what the ions are helps you out, though you don't necessarily have to run to the ion chart every time, as you'll see. So if you don't have the ion chart, try to grab that quickly. Okay, now, the key to writing balanced chemical equations that we'll be doing here is to identify the reactants. What the reactants are will tell you what the products are. There are half a dozen or so different types of reactions that we'll be looking at. And each one of them is fairly systematic, formulaic. If you say, okay, well, it's an acid and a metal, and the first ones we're going to be doing here, well, then it's going to form hydrogen gas and a salt, end of story. So it's not quite as challenging as you might think after you've identified the type of reaction. Right. Now, I'm going to have to go through this pretty quickly. We have just under half an hour, so forgive me for going through it as quickly as I am. But I'm recording this, so if I'm going through it too fast, you can kind of replay it. And I'll also have the entire notes online, the pre-notes that you just filled out. You'll have the full notes later. I'm not going to be doing an Edpuzzle or anything. You'll have the full notes and this video that I'm recording right now. All right, so the first type of reaction is a acid and a metal. And so as you saw in your notes, if it's an acid and a metal, then it's going to form hydrogen gas and a salt. So hydrogen gas. Now the salt will be an ionic compound formed from an anion of the acid. So let's look at our acid. Our acid is you don't need to worry about the names of the acids. I don't know, I might do it sometime in this unit, but I will be referring to the names of the acids, but don't be concerned about knowing those names. Now, this is an acid, so it gives off hydrogen ions, and what's left in this case is ClO2. That's the chlorite ion, and it has a -1 charge. You'll find that on the ion chart. However, you don't really need to look on the ion chart because you can deduce what the charge must be simply because there's only one hydrogen. If there was two hydrogens in the acid, well, then the anion would have to have a -2 charge. If there was three hydrogens, then the anion would have to have a -3 charge. So, all right, so when we form our salt, it's going to be zinc chloride. And you need to know what is the charge of zinc. For that, you'll need to refer to the ion chart. And the ion chart, you'll find zinc, which is a transition metal, has a +2 charge. So the formula for zinc chloride is Zn and then ClO2 taken twice. So zinc is a +2 charge, chloride -1. So that's the formula. Now, as you saw in the notes, what we're going to be doing is treating all salts as being aqueous. Now, in fact, that is not true, and some of the salts we'll be looking at here are not aqueous. However, it's not really worth our time to go through the solubility table and everything for those few ionic compounds that are not aqueous, and IB could care less about that, so I'm not going to make a big deal out of it. So all acids are aqueous, and that's always true. And the other ones that I had listed in the notes, just follow that. But the ionic compounds we'll just treat those as all aqueous. Okay. And then, of course, we need to balance the equation. So I have 2 chlorides here. So to balance that, I need to put the 2 here. Now, I underline my coefficients just to point it out to you. That's not a standard way of doing anything. And so then that would be our balanced equation. That gives us 2 hydrogens, which we need here. You have 2 chlorides, which we have over there, and 1 zinc, 1 zinc. Now, when you write your balanced chemical equation, before you do that, you have to make sure you have the correct formula. If you have an incorrect formula, then you likely will not be able to balance the equation. And I've had over the years, I've had students get really angry. Like they'll come in the next day angry that it's like I gave them I wasted an hour of their lives asking them to balance an equation that can't be balanced. But the problem was that they had the wrong chemical formula for one of the compounds, and then it won't balance. So don't just gloss over the chemical formula. That's an essential component in balancing the equation. Now, okay, the next one, this is cyanide. And what I'm doing, I'm simply writing the ions below to help you out. You don't need to do that. So hydrogen's +1 charge, cyanide's a -1. Aluminum, when it becomes an ion, has a +3 charge. So we have our hydrogen gas, and then our salt would be aluminum cyanide. So aluminum and 3 cyanides. Now, how do you know aluminum is a +3 charge? You have to, that's the ion chart. That's the like I said earlier, you don't really need the ion chart to figure out that's a -1 charge because there's only one hydrogen. But to deduce what charge an element will have that becomes an ion, you need to look it up. All right. Now, once you have that, then we need to balance the equation. You have 3 cyanides here. Now, if I put a 3 over here, don't do this, this will end up being wrong. If I put a 3 over here, that'll balance the cyanides, but then I immediately have a problem because that's 3 hydrogens. And over on this side, I have 2 hydrogens. And so you have that odd-even problem. Anytime that you have an odd-even problem with a particular element, almost always a diatomic element, then just double everything, and that almost always takes care of it. So rather than a 3, if I make that a 6, then that gives me 6 cyanides. Then over here, I need to put a 2 to give me the 6 cyanides, which gives me 2 aluminums here. And then to balance the hydrogens, 6 hydrogens, need a 3 here. And then last, copper, you might remember from the notes, there are 4 elements that are unreactive with acids. It's copper, silver, and gold, and they're all in the same group on the periodic table, and they're transition metals, and then platinum off to the side. If you have one of those 4 metals reacting with an acid, most acids, there's going to be no reaction. All right, and again, this is because this metal is one of those 4 that's unreactive. Okay, I know I'm repeating myself here, but again, the crux of this is identifying what the reactants are. Once you've identified what the reactants are, then you simply plug in what are the products. If it's a metal and an acid, hydrogen gas and a salt. Okay, the next one. These are the neutralization reactions. Neutralization reactions are when you have an acid reacting with a base, and it's called neutralization because the acid neutralizes the base, or we could say the base neutralizes the acid. There are 3 different types. This is the first type. It's a metallic hydroxide, and we really don't even need to say metallic hydroxide. It's just a ionic compound that contains hydroxide. So if hydroxide is in the compound, then it's a metallic hydroxide reacting with an acid. And in that case, we always form water and a salt. So as soon as you see an acid and a metallic hydroxide, just write water down. Water is a liquid, not aqueous. And then the salt will be the cation from which will be the metal, and the anion from the acid. Magnesium has a +2 charge, and and chloride has a -1 charge. To balance the equation, put a 2 here. That'll give me 2 hydrogens, but I also have 2 hydrogens here. So I need to put a 2 here to give me the 4 hydrogens I need, and that'll also give me the 2 oxygens that I need here. I always enjoyed this kind of stuff when I first was learning it. It's kind of like a little puzzle and piece it together, and it looks pretty cool. Okay, now this is, you might remember from last year, acetic acid. And the acetate ion is on the ion chart. It's the first one in the anion section there. And you can see that it's listed in 2 different ways. This can be rewritten. This is acetic acid. However, this is the way that we will be doing it because this is an organic acid. When we get to our unit on organic chemistry, you'll have a better understanding on why it's written like that. But don't worry about it. This will be the only acid that is written kind of backwards. All other acids, the hydrogen is in front, but for organic acids, the hydrogen is at the end. So what this is the acetate ion and hydrogen. It's just kind of backwards. If we were to do it the way that we would typically do it here in the States, it would look like that. So these are the same things, but we're going to be using this. So again, it'll form water and a salt, and in this case, the salt will be potassium acetate. And that's already balanced. Now, understandably, you'd say, well, if the hydrogen is at the end here, wouldn't I put the potassium at the end too? And in fact, you will see it like that, but that's not the preferred way to do it. Okay, so this is the first of the 3 types of neutralization reactions, hydroxide and an acid forming water and a salt. The next has exactly the same products, except instead of a metallic hydroxide, it's a metallic oxide. So an acid and a metallic oxide will form water and a salt. So water, and the salt will be calcium sulfite. So again, you can deduce what the charge is on your anion would be a -2 charge because there's 2 hydrogens. Calcium is an alkaline earth metal. You might remember that that group is a +2 charge, or you could find it on the ion chart, but you might also remember oxygen's always a -2, so -2, +2. So calcium sulfite that, and that's balanced. Acid, a metallic oxide, water, and a salt. Okay, now the next one is a little challenging because we need to deduce what the charge is on iron. You might remember iron can have more than 1 charge, but we can deduce that fairly easily if you remember that oxygen is a -2. So if oxygen is a -2, and there's 3 of them, that would give us a total of -6. So we want a +6 from the iron. So if we only have 2 irons, it must be iron with a +3 charge. Now, in these reactions, don't worry, the ions will not change charge. So iron's not all of a sudden going to be a +2. It's going to remain whatever charge it is. Okay, so we have a little bit of time here. Why don't you see if you can balance that before I do it? See if you can complete and balance that. So we know that it's going to form water. And the salt will be the iron and the nitrate. Iron with a positive 3 charge, and so we need 3 nitrates. So it needs to be in parentheses. And then we have 2 iron. Now, we can kind of go back and forth on strategies of balancing the equations, but don't have an awful lot of time. Usually I just look at the compound that's kind of the more complex. So I have 2 irons here, 3 oxygens here, so let's balance the irons. That gives me, and then it's kind of a snowballing effect from there. So once I put the 2 in front of here, it's going to affect everything. So I now have 6 nitrates. So on this side, I would need to put a 6 to balance the nitrates, which gives me 6 hydrogens. So on this side, I need to put a 3 to balance the hydrogens, which gives me 3 oxygens, which is what I have here. So we're good. All right, so that's the second type of neutralization reaction. So the first was a hydroxide in an acid. Here it's a metallic oxide in an acid. And the last one is ammonia in an acid. Now, why ammonia? Well, you might recall from last unit, remember the Haber process. Ammonia is just a really important chemical. It's seen all the time, and so it's kind of a category all of its own. And in this case, it's not going to form water and a salt. It's only going to form a salt. And the salt will always be ammonium something. The ammonia is our base, this is, of course, the acid, and so this is going to be our proton acceptor. It's going to take in a hydrogen to form ammonium. And so the first one here will be ammonium nitrate. Oops, nitrite. No parentheses, you don't need more than 1 of each. But for the second one, ammonium is a positive 1 charge, but sulfate here is a negative 2 charge. So for it, I'll need 2 ammoniums. And then to balance this one, I would need to put a 2 in front here. Okay, so those are the 3 types of neutralization reactions. The next involves carbonates. Please speak up if you have a question. Try not to ignore you. Now in the example, it was bicarbonate, but here the practice is just carbonates. So the first one was perchloric acid. And potassium carbonate. Oops. By the way, the potassium carbonate, I have it as a solid, but you could dissolve it in water and then have the reaction take place. That doesn't really matter, but here we're going to treat it as a solid. Now for the case of a carbonate or a bicarbonate reacting with an acid, you'll have 3 products, and the products are always carbon dioxide, water, and again with the salt, the salt. In this case, it'll be potassium perchlorate. Potassium has a positive 1 charge. Perchlorate has a negative 1. You have 2 potassiums here, so we need to put a 2 here. Balance the potassiums. That gives me 2 perchlorates. 2 here. And then that would be it. The next one, phosphoric acid. And calcium carbonate. So why don't you see if you can balance that one? Okay, again, it's formulaic. You just plug it in. Once you recognize what it is, well, it's going to form carbon dioxide, it's going to form water, and salt. Carbon dioxide, water, and the salt will be calcium phosphate. For this, calcium is a +2 charge, phosphate is a -3 charge. So if you messed up on this, you might want to kind of do what I'm doing here for your notes, kind of write down what you're dealing with. You can see that they're not going to just combine 1 to 1. It's a +2 and a -3. So calcium phosphate, you need 3 calciums and 2 phosphates. Then to balance the equation, I have 2 phosphates here, 2 here. You have 3 calciums, 3 here. That gives me 3 carbons, 3 here. And this gave me 6 hydrogens, so I need a 3 here. So I kind of saved that one almost to the last. If you are able to do that, if you just got that, then you're in pretty good shape. Okay. But you can see that you need to keep your eye on the ball. If you just wrote calcium phosphate 1 to 1, that would be a case like I was talking about earlier, where you're not going to be able to balance that equation because that's not the right formula. Okay, so acid, carbonate, or bicarbonate, carbon dioxide, water, and salt. The last one is one that you saw in our unit on periodicity. Remember when we went across period 3 oxide, we looked at the chemical properties of period 3 oxides. And when we got to the non-metallic oxides, when they react with water, they form oxyacids. And so sulfur trioxide reacting with water will form sulfuric acid. You just combine them. And you might remember also from our last unit, the contact process. Remember the contact process was the ultimate product was sulfuric acid, but we never really looked at it. We looked at the formation of sulfur trioxide. And that was, the equilibrium of the sulfur dioxide and oxygen to form sulfur trioxide and the maximum pressure, or the ideal pressure and temperature for forming it. The last step, though, is real easy. Just put it into water, and there you have your sulfuric acid. The last one is phosphoric acid. And to balance this, I need to put a 2 here, balance the phosphorus, and a 3 here to balance the hydrogens. Okay, so that is your homework. You have 18 problems, and they're kind of scattered. Some of them are kind of clumped together, but they're kind of scattered. So the secret to solving this, or the trick is to, as I've been saying over and over again, is what are the reactants? So once you've identified the reactants, then you know what the products are. You just need to piece it together. All right? Any questions before I stop this?
I have a question.
Yeah. Yeah.
How did you get 3 hydrogens in the product?
Here?
The last one.
Here?
Yeah.
Well, phosphoric acid, well, actually, this is not one that you would have been able to deduce easily. So I kind of threw, I guess I kind of threw this at you. But phosphate has a -3 charge.
Oh, okay.
Okay.
Okay, that makes sense.
Now, in fact, on your homework, just between you and me, on your homework, I'm only giving you one of these, and instead of sulfur trioxide, it's sulfur dioxide.
Okay.
Okay, and that'll form, I don't know, something like sulfurous acid.
Okay, thank you.
You're welcome. Okay, so you have the homework assignment that's due tomorrow, the properties of acids and bases. Oh, and then this assignment is due on Thursday. Now, the only assignment that you have due on Thursday is writing the balanced chemical equations. However, in the notes that you were taking, you probably noticed the last few slides are just kind of some general properties of acids and bases. So copy that down, but there's no homework on it. I'll kind of pick up that story on Thursday. All right? I think that's about it. Okay, hopefully this recording came out, and I will post it later today on YouTube channel. I'll send out a message. Okay.
Thank you.
Okay, bye-bye.
Have a great day, Mr. Massey.
You too.